Okay, in this video what I want to do is show you how to actually solve to find the values of the unknown constants in some of these particular solutions. So I'm going to do this in example from the first one we did. So the first non-homogeneous recurrence relationship we had was this one here, and I told you that the solution to the homogeneous equation was hn equals a 5 to the n plus b, and we were considering when f of n is 2 to the n, so p of n equals a 2 to the n. So what we're going to do is we're going to take this relationship and we're going to substitute pn equals a 2 to the n into that relationship. So let's think about what that's going to give us. That's going to give us, if Pn is a 2 to the n, Pn minus 1 is a 2 to the n minus 1, and Pn minus 2 is a 2 to the n minus 2. Well, we are substituting that into un equals 6un minus 1 minus 5un minus 2 plus 2 to the n. Okay, well, let's put those in. So we have Pn equals 6 lots of Pn minus 1 minus 5 lots of Pn minus 2 plus 2 to the n. Well, what was Pn? That was a 2 to the n. So we have a 2 to the n equals 6 lots of Pn minus 1, while Pn minus 1 was a 2 to the n minus 1. So we have 6a 2 to the n minus 1, and then we have minus 5 lots of a Pn minus 2, so 2 to the n minus 2, plus 2 to the n. Okay, well, what could we do here? Well, we could definitely divide throughout by 2 to the n. So what we would get there if we divide out by 2 to the n is going to be a equals 6a, and dividing this by 2 to the n, we get 2 to the minus 1 minus 5a. Dividing this by 2 to the n, we get 2 to the minus 2, and we divide this by 2 to the n, we get plus 1. Well, we could do this in terms of fractions. It's probably actually going to be easier to multiply through by 2 to the 2, so multiply through by 4. So we're going to get 4a equals, well, 2 to the minus 1 times by 4 is a half times 4, which is 2. So 6 times 2 is 12. So we get 12a. 2 to the minus 2 times 4 is 1. So we got 12a minus 5a plus 4, because we've done 1 times 4. Well, we can use this to work out what the value of a is. So what do we get there? We get 4a equals 7a plus 4. So actually, what have we got? We've got minus 3a equals 4. So a equals minus 4 over 3. So that gives me a particular solution of Pn equals minus 4 over 3 times by 2 to the n. And then if we want to solve the non-homogeneous recurrence relation, we know that the general solution un is the solution to the homogeneous equation. Add the particular solution. Well, I told you that solution was a 5 to the n plus b. Add on, well, actually it's going to be a subtract. So subtract 4 over 3, 2 to the n. And if you are given something about the first and second terms of this sequence, you could then calculate the values of capital A and capital B. So for example, if you knew that u0 were equal to 1 and u1 were equal to minus 3, you could substitute in that information and use that to calculate A and B. But I'm not going to do that now.